My name is Ibram, and I will start with the first input of our project, which is an infrared sensor. What the infrared sensor mainly does that it sends FPGA a digital signal when any object passes through it. And it has three connections, which are the Vout and the ground and the VCC, which works as the main the power supply of the sensor.
My name is Mohamed Hesham. I'm going to talk about the light system in our project. First of all, the IR sends a signal to the FPGA. Then the FPGA sends a signal to the light system. The light system consists of 6 LEDs located all around the house. Whenever the IR detects something or detects an object, the light system, all the 6 LEDs lights together. They are connected in series. We didn't use an external power source. We instead used the 3 voltage from the FPGA.
My name is Hazem alim. Today I'll talk about smoke sensor. Smoke sensor has 4 pins. This is smoke sensor. Is inside the home. Smoke sensor has 4 pins: VCC and the ground and digital and the analog output. Which we use the digital signal to send it for the FPGA, and then FPGA will understand it and analyze it. We use the digital signal, digital output signal, because analog digital converter needed 12 volt. However, the FPGA handles only 3 volts. So we needed to another power supply, output power supply, to handle this power or handle these volts. So it was hard for us to find. So we used the digital output. And thanks.
My name is Danial Malak, and I'm gonna illustrate the buzzer, which we have here in our project. The buzzer is connected with two wires. One is the ground, and the other is the signal, which comes from the FPGA. Okay, and to note, the buzzer has polarity. So if we switch these 2 wires, it won't work. Okay, and this the signal which comes from the FPGA. It comes from the smoke sensor, which we have here. Okay, to alarm the house of a fire. This represents the alarm system in houses or hospitals or any institute. Thank you.
My name is Mustafa. I will present to you an overview to the project and the phases we followed during the implementation. First, we started by designing this maquette. It didn't take much effort. We've put the LEDs in the sides of the walls, and on the other side, we've put the smoke sensor upwards, as it happens in real world, and the buzzer in the side. Then the second phase, we started by writing the code. The first module was to sense a presence in the house and turn on and off the light system eventually. The second module was the buzzer module, which works by detecting the smoke, the reading from the smoke sensor. And finally, the smart house module, which integrates the other modules together. And then we started by making the circuit connections and the bit planner assignment. The first pin is the person, which takes the reading from the infrared sensor. The second pin is the person out, which is output signal from the FPGA, which is given to the LEDs. the third signal comes from the smoke sensor, and the fourth one is the output signal from the FPGA going to the buzzer. And then we have the VCC of the FPGA, which is 5 volt, and the ground of the FPGA, which is connected to an external circuit to produce a common ground for all sensors and all other components, like the buzzer and the LEDs. And here we have a common VCC.